Okay, my friends, I think this is extremely important and I feel compelled to speak out right away. This just came out. This supercluster from a rare soil microbe could yield some amazing new drugs. Well, virtually everything there is in chemistry is made by bacteria, 100%. They make enzymes and catalysts that are so sophisticated, we can't even make them the way they make them. All right, anybody that knows my research understands that I've been extremely aggressively talking about enzymes and catalysts, and they are produced by bacteria. We have good bacteria, we have bad bacteria. Both of those are required in your body. You can't get rid of your bad bacteria and be healthy. You have to have that bad bacteria to create chemistry that damages things. And it damages things in a way that they can be broken down to be removed by the good bacteria's, working on that to break it down and get it into the system to drive it away. Because all of your blood cells and so forth are taken care of by good bacteria. They create mucus, they create all of the catalysts and the enzymes to break down the food and give you the mucus and all that stuff. But sooner or later that blood cell dies. You can't use that same chemistry of those enzymes and proteins and so forth to break that thing down. Now it's just dead living in your body. You have to have bad bacteria come in and say, ooh, look at that dead thing. I can see there's a little molecule on it that says I'm dead now. And it's called apoptosis. And it goes over there and it just eats it up and turns it into little bits and pieces. And then it goes out through your system. If you don't have either of those enzymes from those bacteria, you can't get those products done. That's what causes skin cancer. Skin cancer is because all over your body you have toxins all over, because they're all continuously on your body. They're in your body, they're in your skin, there's sunlight is killing the bacteria that live in there. You get too much sunlight, it kills the bacteria. That's the problem. And then once the bacteria is gone, you're invadable by bad bacteria. It just breaks through the cell linings and causes stage 1, 2, 3, 4 cancer, because it's more and more invadable. So it's the bacteria that's being killed. We need to produce enzymes, bacteria that produce these enzymes, rather than just trying to flood the body with the enzymes. All right, so here it is. It has unusual biology, this one particular thing they found in dirt. Really, all they did was found it in dirt, because it's everywhere. The dirt has to be broken down too. So they break out. That's what decay is. It's enzymes, enzymology. All right, so it has unusual biology encoding for unusual enzymology. That means bacteria that break down things using enzymes, and they are extremely potent. I'll talk to you about enzymes and catalysts in a minute. But this is driving the production of unexpected chemistry, all harbored within a largely overlooked group of bacteria. They just don't look for these things. Says this so-and-so of this flavor of Apoptosis. Now let's just read it again in one continuous statement. This particular type, well, let's start right here. Being more difficult to find in nature than other bacterias and harder to grow in a lab, this specific bacteria has not been studied nearly as much as its more common drug-producing relatives. They use other bacteria to create drugs that they're familiar with, and they know from, I don't know exactly how they figured it out, but every bacteria creates an enzyme, and every enzyme has a chemical reaction. All right, so they found this particular new strain of bacteria living in dirt. And what the researchers found was quite odd. All right, this particular new bacteria has unusual biology encoding for unusual enzymology, driving the production of unexpected chemistry, all within a largely overlooked group of bacteria. So that's not just one bacteria. They got a lot of work to do about this, and they know this. And it comes down to at the end, it says this is very interesting. And the enzymes, let's talk about enzymes and catalysts, because you got to understand this. If you want to be healthy, you're going to have to start thinking for yourself. Okay, before we go any further, I am not a doctor. I make no recommendation about doing anything with anything. I am just telling you what my research has turned up. That's the end of it. I'm not a doctor. Do not take my advice. All right, I'm just going to read you this straight through and then I'm going to explain it to you. Enzymes, which we were just talking about, are proteins, and they help speed up metabolism, or the chemical reactions in our bodies. Metabolism is the chemical reactions. They build some substances, and they break down others. All living things have enzymes. All living things have enzymes. All living things have enzymes. Our bodies naturally produce enzymes. No, they do not. Our bodies produce nothing of the sort. Bacteria produces the enzymes, not our bodies. All right, listen to this now. These are all problems with bacteria not being present or having too much of something that can't be controlled by other bacteria. It says, when should I call a doctor about enzyme problems? You won't know if you have an enzyme problem without a blood test. Contact your doctor if you experience any of the following problems. Just about everybody has this stuff nowadays, unless they are taking heavy amounts of probiotics and prebiotics. Because you know, all the abdominal pain, well, what is that from? It's from bloating or gas. It's from poor digestion. Diarrhea, same thing, poor digestion. Fatigue, you're not getting the nutrients and so forth to your blood cells because you're not absorbing the products correctly because you have all these things. Nausea, vomiting, you can't hold the food down. It's not being dealt with correctly in your upper intestine, in your guts. Unexplained weight loss, you're not absorbing. Low red blood cell counts. You have anemia, you're just not being able to keep those blood cells alive because the bacteria that protected them isn't there. Gastrointestinal bleeding, you're breaking through your membranes in your guts. This is a note from Cleveland Clinic. Enzymes help facilitate biochemical reactions in their bodies. Exactly. They aid in everything from breathing to digestion. 100% of everything that happens in your body is done by enzymes, which are only created by bacteria. Enzymes don't just happen spontaneously. And the bacteria have to know what enzymes to create, and they do that, and I'm going to show you they figured out that everything's wrong that they've been talking about. It says your textbooks are wrong. I'll show you that in a second. It's having too little or too much of a certain enzyme can lead to health problems. Exactly. Some people with chronic conditions may need to take enzyme supplements to help their bodies work as they should. Only take enzyme supplements under the supervision of your healthcare provider. Best to have your body create these enzymes automatically. Let me show you about enzymes. This is so important, it's unbelievable. All right. Take a second and think very, very carefully what I'm about to explain to you. All products are created by chemistry. And enzymes and catalysts affect the rate of a reaction, a chemical reaction, without being consumed in the reaction themselves. They facilitate it, and they do not even get used up. Now, all known enzymes do that job, and they are catalysts. But not all catalysts are actually enzymes. Well, what's the difference? Enzymes are organic biocatalysts. They're biological. They are in creatures' biology. Now, they're actually created by bacteria, and they know this as well. And it has a high molecular protein, and you should see the size of these proteins, yikes. All known enzymes are catalysts. They all do the same job. Enzyme reaction rates are faster. They're so fast it's unbelievable. And I'm going to tell you exactly how fast. They increase the rate of chemical reactions and convert whatever it's hitting into a product. The substrate is whatever it's penetrating into, and they turn it into a product, whatever that product happens to be. And these enzymes can create virtually everything there is because they are so sophisticated. When I show you what these enzymes look like, you're going to freak. They are highly specific, producing large amounts of good residues, which are these products. Carbon-carbon and carbon-hydrogen bonds are present, which is all life. That's all life. Carbon-carbon, carbon-hydrogen, that's just all life. Two types include activation and inhibitory enzymes. That's exactly it. Push to shove. You stay where you are, and I'll stay where I am, and we're good to go. You kill the stuff that I don't want to deal with, and I'll kill the stuff you don't want to deal with. I'll come out and get the food. You come in and get the trash. That's the way they work together. And they say, so some of them activate and some of them stop things from happening. That's the examples include lipase and amylase. They're just two different types of these catalysts. Of enzymes, which are catalysts. Then you go into the catalysts. They say it's inorganic. Well, it's low molecular weight. All catalysts are not enzymes because they're manufactured sometimes. Examples include vanadium oxide. But this is what we're looking for because we're in biology. That I'm not too concerned about. All right, I'm not going to bore you with all the details, but just think of it this way. Enzymes is the thing we're talking about that are created by bacteria, are proteins. I'm going to show you in a second how complicated they are. And they're comprised of amino acids, which are little building blocks, linked together in one or more polypeptide chains. That's just a series of them. All they have to be exactly an exact sequence. This sequence of amino acids is a polypeptide. Let's look at what they look like. That's going to be more impressive than all the gobbledygook that goes along with it. Look at these things. Look at this. Enzyme versus protein. Here's an enzyme. You know how many molecules are in that thing? This thing is absolutely, and it's exactly identical every single time. They have to be the same or they don't do the job. Look at these things. And there is like 80,000 or so different bacteria, they claim now, they think. Yes. Can you imagine how sophisticated that is? And that's been done by bacteria. And it does it like instantaneously. It's like spontaneous combustion, how quickly they make these bacteria. Very, very, very elegant system. And once your bacteria dies, look at that. I mean, come on. And they curl up and all these things, and then they go out through the body and attach to things. And I can show you that actually occurring. Just recently they discovered it. All right, this is stunning. This is Seeker. And this is Gokul. I think this is University of California. I'm not sure about that. But anyway, he's going to talk about this new discovery. And I'm going to set it up for you. They discovered a new way to look at the molecules in the body as you're still alive and see these things happening, and they can change it. They can see them by the different colors that they give off. Again, it's transition metals that are in these molecules that give them their colors, and they're using a special way of filtering it now so that it's not so invasive that it blows them up. They can just barely, well, they see them fabulously. I'm not even sure how it works, but it works pretty damn good. Let's go with that. All right, here goes Gokul. Here he is. He's hairs on his arms stood up because every hair has a muscle. I'm not kidding you. It's true.
I remember the moment. It's something I will never forget. The hair on my hands just stood up. It's a microscopic universe within each cell.
This is an unprecedented view of the cellular world, where we can actually see immune cells scooping up sugars in the ear of a zebrafish in real time.
Focusing only on the crawling immune cells, we've noticed two classes of them. One was not hungry at all, but it was very active in terms of trying to figure out, what the environment is. There was another one that was kind of slouching around with a lot of food in its belly. We can actually conceptualize and visualize and analyze the contents of each of these cellular compartments in this crawling immune cell as it's kind of, scooping up its environment. I mean, that is a level of details no one's seen before.
We're living in a new era of cell biology, where microscopy advancements are giving biologists the opportunity to reveal the hidden patterns of cells. What we expect to learn from here on out will transform our understanding of human health and rewrite the textbooks on the fundamental unit of life.
All right, let's examine what Gokul talked about in the first minute here. All right, so he's looking at this for the first time. They're seeing this.
Something I will never forget. The hair on my hands just stood up. It's a microscopic universe within each cell.
This is an unprecedented view of the cellular world, where we...
All right, let me just explain what you are seeing here. Inside of the interstitium, which is all of this fabric-y looking stuff, which is in a layer of tissue that's think of it as the membranes, because that's exactly what it is. It's a membrane. And in these membranes, these cells exist, which are your immune cells. And in this interstitial fluid, which is a fluid that just runs through the whole body, and it runs fast. When you take in drugs and stuff, they go through your body very, very quickly. And here's what happens. He talked about a sniffer cell. That sniffer cell has activated this biological, whatever it is, it's a bacteria probably. And it ran around here and gobbled up all of these little, maybe it's mucus, maybe it's some form of a catalyst or an enzyme, and that's going to take it out and deliver it to wherever the invasion is. Let's call it an invasion at this point. But it also brings stuff out to bring it out to break down food. And your tonsils and all that stuff, they say they don't do anything. Well, I think they actually activate the bacteria by it's passing by your tonsils, and the bacteria in your tonsils says, "Ooh, I see that. Ooh, you better tell him he's going to have a taco here. You're going to have a problem. Oh, there goes the chili. Oh my God! Get out there! Slime, mucus." And if you don't have that, well, you got problems. You got a hot tamale. Okay, I'm sorry, I got severely interrupted. Whoops, I'm sure I showed you all this stuff in great detail. If not, I will. But these are the transition colors, and this is most important that we understand these extremely aggressive molecules, which are really used to make proteins by the bacteria, which the proteins are catalysts and enzymes, and they are very, very sophisticated. All right, you have to understand how unbelievably amazing enzymes are. Enzymes are extremely efficient in speeding up biochemical reactions. I guess so. They can catalyze, means to change, up to several million reactions per second. Several million in 1 second. And that's with an enzyme, and the enzyme itself doesn't even get used up. It goes on the next second and does another several million until there are no more to catalyze. Then it's done and it just gets flushed out of your system. Nothing is more elegant than these enzymes. And every bacteria creates only one enzyme. All right, like I said, I got severely interrupted, so I might have gone over this, but I'm going to go over it again. Very important. Every different bacteria creates only one enzyme, and there are thousands of individual enzymes in the body. They say there's like 80,000 different bacteria now, and they live in your membranes, and that is where they create all those little things that Gokul was showing, and we're going to go back to that in a minute. Now, there's thousands of these enzymes in your body. Each type of enzyme only has one job. It does one specific exact thing. The enzyme sucrase breaks down a sugar called sucrose. If you can't break it down, you don't have that enzyme, you're screwed. And if you don't have the bacteria to create that enzyme, that's why you don't have the enzyme. Now, lactase breaks down lactose, a kind of sugar found in milk products. People say, oh, I can't eat this, I can't eat that. Then you have the ones that do carbohydrates. Then you have fats and fatty acids and proteins and amino acids. So if you don't have those enzymes, you're in trouble. And if you don't have the enzymes, it's because you don't have the bacteria living in your active sites. All right, so here we are back at Gokul, Seeker. Here we go. He's going to let's go back to the beginning again, because this is just so important. It's unbelievable. They have missed a lot because
stood up.
We
It's a
never knew this
microscopic
before.
universe within each.
As a matter of fact, it says your textbooks are wrong. This is what cells actually look like. You see that now, right there. You see the name of the. All right, here we go.
cell.
This is an unprecedented view of the cellular world, where we can actually see immune cells scooping up sugars in the ear of a zebrafish in real time.
Now they're saying scooping up sugars. I say no. This is an immune cell. It's scooping up mucus or whatever it is. Now see these colors? Remember I showed you the transition metal colors, and that's what it's doing. It's using these transition metals to grab a hold of these things. That's why we're seeing the colors.
Time.
Focusing only on the crawling immune cells, we've noticed two classes of them. One seems
Look at the colors on this thing. What is it doing? It's going out sniffing around. It's using all its different
not
colors to
hungry at all,
sniff.
but
You
it's
see it?
very active in terms of trying to
You see what it's doing? Look at this. It's sniffing around for different frequencies of colors and
figure out
molecules.
what the environment is. There's another one that was kind of
Okay, so again, let's just go back. Again, it's so important to understand this. Here he is sniffing around for anybody that is an invader. And he's using all of these different frequencies and stringing it along to see if there's any molecules out there that are offenders. And if there are, he reports back to this new guy
different in terms of trying to
in the
figure out,
cell.
what the environment is. There's another one that was
All right, so now this guy gets the message and says, hey, we got a problem out here. He said, what's the problem? He said, well, we got somebody that's trying to nibble through the digestive wall. And he says, just throw some mucus at it and see if that takes care of it. So this guy says, oh, yeah, I got some mucus down here. I'll go grab them up. We're going to use the blue molecules. They attach to that kind of mucus. All right, so now that guy's running around gobbling up mucus.
sloshing around with a lot of food in its belly.
Mucus in his
Actually
belly.
Conceptualize and visualize and analyze the contents of each of these cellular compartments in this crawling immune cell as
By the color of it, because the colors dictate what the actual product is within that cell and what it's harvesting.
it's kind of scooping up its environment. I mean, that is a level of details no one's seen before.
We're living in a new
You see all these different colors? They're scanning through some kind of biological part.
era
Now
of cell
watch.
biology, where microscopy advancements are giving
You see all these different colors? Those different colors represent different chemistry. That different chemistry,
biologists the opportunity to reveal the hidden patterns
You
of
see it?
cells. What we expect to learn from here on out will transform our understanding.
let me just explain you something. Let's say we looked at the normal tissue of a pancreas, and it looked just like this. Well, what would happen if you looked at this and 50% of these purple ones were black, or they were blue, or something was different about them? There was some collection of chemistry that was attacking some of these, or maybe all of them, who knows? But if you see a pattern of chemistry by color, that indicates what biological processes and enzymes and chemistry exist in that exact spot where that light is lighting it up. And if it comes back blue, it means one thing. If it comes back pink, it means something else. If it comes back black, it probably means something bad. I don't know. But it would certainly be something we would find out very quickly if they use this technique correctly.
Understanding of human health and rewrite the textbooks on the fundamental unit of life. For centuries, microscopes have illuminated previously invisible worlds. We've learned how cells divide and even discovered the existence of bacteria and microorganisms.
All right, they're going to go on through some stuff. I'll try to put a link to this. It's very interesting, and this new technique gives us unbelievable abilities. You see all the little blood cells? All right, and the bacteria and the microorganisms, they're living in them. And they're checking things out. They're doing all kinds of things. So anyway, sometimes they're good, sometimes they're bad. I don't know. That doesn't look like something good, but who knows? Okay, here's Go Call again. Now he's talking about how viruses enter cells. We have to understand this because they're penetrating membranes, and the membranes are only protected by the bacteria that lives in the membrane. Every cell has a membrane.
For instance, if you can understand the mechanism by which it's fusing to the plasma membrane and then injecting its contents into.
It's got to get through the membrane first. The membrane is your immune system. That is literally your immune system. If you can protect yourself at your membrane level, you're good to go. And the only thing that is in that membrane that protects you is bacteria that works for you. It creates mucus, it creates enzymes and catalysts and all of the good stuff. It allows the portal of good things in, because you need nutrients. You can't let that guy come in, but you can let good stuff come in. The only way that can be done is bacteria. They regulate. They're the gatekeepers. This guy should have never been allowed in here. Once he's in, it's all over. And if there's enough of them that don't have the good bacteria, you're invaded. You're just wide open. They call that pre-existing conditions. Oh yeah, he's immunocompromised. Of course he is. He doesn't have the bacteria living in the membranes to protect you. All right, don't forget, these are transition metal colors, and they're going to be opening this up
With
to...
tools like these soon coming online, biologists like Susan are excited about the next decade of cell biology.
Look at this. Look at these patterns. I understand all of this because I have seen all of this in my geobiology.
We basically have a little, alien world that none of us can wrap our minds around. And it's
That's right. None of us can get our minds around it yet, but it's coming.
all of these technologies that are allowing us to start to do that more intuitively. Imagine a world where you could look at a cell and you know what it's doing, what it has done, and what it will do.
Okay, this is important to understand. This is a nutrition bulletin, and this is about from the National Institute of Health, National Library of Medicine. Food additives assessing the impact of exposure to permitted emulsifiers on bowel and metabolic health. This is the thing that kills you, is your stomach. Bowel and metabolic health. This is the abstract. Emulsifiers are common components of processed foods. They're consumed as part of a Western diet. They're not normally found in nature, basically. Emerging in vitro cell line culture, mouse model, and human intestinal tissue explant studies have all suggested that very low concentrations of the food emulsifier polysorbate 80 may cause bacterial translocation across the intestinal epithelium, intestinal inflammation, and metabolic syndrome. This particular chemical causes the bacteria to die, apparently. Bacterial translocation. What does that mean? The bacteria goes away. It raises the possibility that dietary emulsifiers might be factors in conditions such as coronary artery disease, type 2 diabetes, Crohn's disease, all of these digestive disorder diseases. Everything is a digestive disorder disease is basically what I'm finding out now. And, this is just out in 2019. It's a bulletin. And then people have to understand what we're really in for here. These are permitted food additives that they always thought could not be absorbed by the body, just pass right through it. Yeah, no problem, they just go in and out. Well, now they're saying even very low concentrations. Which means, and I believe right now we're starting to be able to absorb them. I believe the bacteria in us have adjusted to these things and say, well, you can't just go through here, we're going to do something with you, and now it's maybe something bad. And because things are not getting better in the health area. Now, there's been reports of association between ultra-processed foods and adverse health outcomes in populations around the world. Allergic, autoimmune disorders, types of cancers, cardiovascular disease, metabolic disorders, all these different things, obesity, diabetes too. So, my take on this right now is these food additives are damaging the bacteria, so you become a target. Now, they can easily determine if this is true or not. But they haven't taken this line of approach that it's the bacteria that is being damaged by all of these chemicals we have, and radiation and all that stuff. And I have some very good examples to show. I had somebody comment the other day that had severe radiation exposure, and they didn't think she'd make it, and she did live. But she had 7 cancers. 7. And I believe they were all different types of cancers, because she was so heavily irradiated, it killed basically every bacteria in her body. So there was no protection on any one of her membranes. So she became so invaded, and they kept working on her. I guess it was a couple of years she lived through it. And then some doctor put her on all kinds of probiotics and prebiotics and all that stuff, and now she's been good. And that was, I think, three years or so ago. I can't remember the details, so don't hold me up to it. But she was, just totally attacked. And I've had a lot of people tell me these kind of same stories, not that serious, but even autism. We've basically reversed autism, not to being back to 100%, but to go from nonverbal at 9.5 years old, where they wanted to put them under, sort of house control, where, locked ward, basically, because they were afraid of, there was no communication, there was, continuous stimming and humming and, shaking and all this stuff. And then after the probiotics, he came back to being quite normal. So because I also found out that the nerves run through the interstitium where all of this bacteria lives. And the bacteria protect the interstitial layers, and obviously if the nerves are running through there, and it appears that that's the case. I'm doing a little more investigation on this, but if the nerves run through primarily the interstitium, and that appears to be the case, that's why they're protected. And if the bacteria isn't there, just like everywhere else, it's not going to be protected. So you're going to have, you may even have bouts of depression, headaches, postpartum disorder they're talking about now is nutritional. It's all chemistry. I mean, you're 100% chemistry. Even your memories are chemical. Because there's something called CPG islands that are your memories. And they were in what they call a junk DNA. 98% of your DNA, they have no idea what it does. They call it junk DNA. Well, it's not junk DNA. That's where all your memories and your responses and all of that stuff, and even immunities, there's programs in there. There's just a bazillion programs. Think of if 2% of your DNA can make your body build exactly the way it's built, with all the nerves and blood vessels and your eyes work and your ears and your hair and every single little bit about you is built into that instruction manual, and that's only 2% of your DNA. Just think of how complicated that is. If you had any idea how complicated the human body is, you would just fall on the floor and say, oh my God, 98% is junk? I don't think so. That's where everything is stored. And I can almost guarantee you that because of identical twins. They have the same DNA when they're born, basically. The stuff that they know how it works. And they say, yeah, these identical twins, identical DNA. Well, what about the other 98%? Well, it's pretty close, and then it starts going, one goes one way and one goes the other way. It depends on their experiences in life and what they come up against, how their bacteria is programmed to respond. Basically, that's it. They create programs. They are just the most elegant little buggers that there ever was. Maybe I didn't show you the proteins, but I sure will now. I think I remember showing you these, but they are so elegant, and that's an exact piece of chemistry. Never changes. If they're going to be good, they're good. If they're not working right, they're not working right. And what creates that is a bacteria. And once that goes out and does its job, it can react with millions and millions of molecules per second to change them. And it sits there and continues to do that job. It doesn't go away. Absolutely elegant. All right, last word. We need to immediately map the entire human body of every single region, because every single region will have different bacteria living in these different areas, coating, let's say, the kidney, where there's a lot of salts, or the liver where there's a lot of metals and acids and so forth, or the stomach where there's a lot of acids, or the intestines where the small intestines a lot of alkaline, and then the rectum and the anus, and all of these different areas have specific bacteria, because the specific bacteria creates a specific enzyme, which is a catalyst, which does a specific chemical job. If you don't have that specific stuff, all that specifics I'm talking about, you don't get the job done. It's as simple as that. It really is simple when you get to the bottom line. It's the bacteria doing a job. It's not your body failing. It's your bacteria failing to support your body. Because you killed the bacteria, most likely with antibiotics or radiation therapy or who knows what. Chemotherapy is destructive to all kinds of bacteria. Radiation kills bacteria. Extensive amounts of sun kills bacteria on your skin and so forth. Simple as that.